Hello, and welcome back to Math 8. This is a video over Section 2, and what we're going to be doing in this section is we're going to be interpreting graphs, okay? Notice how I've changed my pointer to a lightsaber, which I think is pretty rad. Okay, so today our objectives, we want to identify clusters and outliers in a scatter plot, analyze the influence outliers and clusters have on the data set, and then explain the meaning of clusters and outliers in context. So, in a scatter plot, you have all these different points on a graph, okay? In a cluster is when a group of data points that are together, okay? So what I want you to see here is that this is graphs with clusters and this is graphs without clusters. And what I notice about a graph with a cluster is that the points are really close together, okay? And they share kind of a trend, okay? Whereas otherwise, graphs without clusters are kind of random, okay? So let's write that down, all right? Let's come in here and let's say a cluster is a group of data points that are together. I want to put that the cluster is points that are close together, okay? They're close to each other, okay? If they're graphs without clusters, we would call them more or less random points on the graph, okay? All right, so what we can do is we can also analyze clusters. So clusters kind of tell us a story, okay? And so what we get, what we ask ourselves is there a pattern of data points grouped together in the scatter plot? And is there a relationship between the amount of time in an experiment and the number of bacteria that have grown? So in this example, okay, we have this thing here. So as time increases, okay, what does the number of bacteria do? Now what we have is we have this group of points, okay? We have a cluster here. And this cluster has a relationship. And what it says is that, you know, as time goes on, the number of bacteria are more or less increasing, okay? So they share this common theme, and what I'm going to do is come in here and I'm going to draw a line that kind of fits the data, and we'll talk all about that. But what we have is this upward trend, okay? And so what we have is that as time increases, so we say this, as time increases, okay, the number of bacteria also increases. Okay? And so that's what we can tell from a scatter plot. So, you know, we're not going to have a nice linear, you know, exact points on a graph that as time increases, oh, the number of bacteria is going to increase by 2 each hour. Okay, but we can look at all these different data points and we can say, all right, yeah, so the trend is that they're going up. As time increases, the number of bacteria are increasing, okay? So now, let's take a look over here. So, okay, let's go over here, sorry. Does the scatter plot have a cluster? So in this, what this says, it says the population of a city and then the amount of rainfall. Now, this is something interesting where, you know, does the population of a city, okay, affect the rainfall? And to answer that question, maybe not. Maybe you would say put this as your independent variable, the amount of rainfall in a city, and then the population. And we're finding is that, you know, maybe that was the case way back when. But now with the invention of, you know, irrigation systems and all that kind of stuff, that's not really something that really, you know, forces people to live in a certain area. That might change in the future, but that's the case. So what we're doing is we're comparing these two. Sorry, a little bit of a tangent. But, you know, the population of a city, as the population increases, does the amount of rainfall for that city also increase? And what we see here is we have a random set of points. There is no correlation. The points aren't grouped together, so there's not a cluster. Okay, so there's not a cluster. Okay, and is there a relationship between the population of a city and the amount of rainfall? And the answer to that is no. There is no relationship. No relationship. Okay. And so that's what we can kind of tell. All right. So, all right. Let's talk about an outlier. Okay. So an outlier in a scatter plot is a point that varies significantly from the rest of the data. Okay. So if I wanted to look over here, okay, over here, in here, our x-axis is the number of cashiers in a store, and then the sales that store has in dollars, okay? And one thing that we understand here is that we do have a cluster here, that there is a trend where if you have more cashiers, then that probably indicates that you are making more sales, therefore you have to hire more cashiers. However, okay, let's answer this first question. Are there any significant outliers? Yes. This one here, this point, is what we call an outlier. And this one doesn't fit the graph, okay? Doesn't fit the pattern. So doesn't, okay, fit the pattern / graph, okay? And, or doesn't fit the cluster, not the graph. Pattern / cluster. All right, and what we, kind of, you have to look at this data and ask questions like, all right, well, obviously these stores, okay, that have, however many cashiers, are hiring cashiers to a point to fit their sales needs. However, over here, you have somebody that has 8 cashiers and they're making $20 in sales. So they're not making as much money. So what you can conclude from here, and let's talk about it over here. Are there outliers in this graph? Yes. And that would be the point 8, 20, okay, is an outlier, okay? But let's talk about, what's going on in this picture, okay? And what you have to ask yourself is this, all right? All these other points fit the graph pretty well, but you have this other one that doesn't, okay? Now, if you've ever been to, and I'm just going to use Summit County, Breckenridge for example, what you find is that, there are a lot of places hiring, okay? And there's a reason for that. But what you find out is that there's a lot of long lines at the grocery store because they don't have that many cashiers, because they can't hire that many people. Now, here's what's interesting. I was there yesterday, and I saw 2 new things that they put in there. They not only put in an extra thing of self-checkout, but they also had these remotes that you could walk around the store with, scan your stuff, and be able to, not have to wait in line and not have to use a cashier to buy your groceries, which is kind of interesting. And they're kind of solving that problem of not being able to find cashiers, okay? And that outlier would be over here. So Breckenridge is an outlier. Breckenridge would be like, they've got 2 and they're making a crap ton of money in sales, but the lines are really long, okay? And so, over here, what you're seeing is that, all right, all these businesses are fitting the data. They're doing a good job of moving people through, hiring enough cashiers to do so. However, this one, they got all these cashiers and they're just sitting there not doing anything. And that's kind of weird. Have you ever been to a grocery store and people are like fighting over you to come in and go through their line? Okay, this is that store, okay? It's happened. I've been to those places. Now, that is neither, this is just a hypothetical example and I'm going off on tangents, but that's what data does. Data tells a story, okay? And that's what's cool about it, because you can look at the data and be like, oh, look what's going on here. And you can make conclusions based on the data. All right, so let's look at outliers in a table. So are there any outliers in this table? So over here, what we see is we see X values of total home runs in a baseball game, X, and the final score of the winning team. So what we see here is that, as the number of home runs in a baseball game increases, typically what happens is that the final score of the winning team also increases, except for this one. This is my outlier. 13 does not fit the data, so this is my outlier. Okay, and what you have to look at is that all these numbers are pretty close, okay? From 1 to 2 to 2 to 3, you're going from 3 to 3 to 4 to 5. Okay, all of a sudden, then you jump up to 4, and boom, you got 13. So that one jumps up really fast, and then all of a sudden you go way back down, and then 6 to 6, 7 and 8, and then 7 to 6. So all these numbers are increasing, not at a constant rate, but they're all getting a little bit bigger as these numbers are getting it bigger, except for the one that had 4 home runs in a baseball game, and then the final winning score, the number of runs was 13. So, we can look at a table to understand that one as well. And what the conclusion that you can draw is that, this team here didn't score as many, they didn't hit as many home runs, but they probably had a lot more base hits and doubles or triples, okay? And they were just running up the score, all right? That can happen, all right? But that's, what we see in that. All right, let's take a look at the next page. Okay, so the impact of outliers. So outliers are people that don't fit the norm, okay? This over here is like your normal set of data. But then you have these other points out here that are outliers, okay? And what I want to do is talk about each of these outliers in context of the problem to show what they mean, okay? And these, don't occur very often, okay? So let's take a look at this. And this says the amount of sleep on the night before a test in hours, and then the score on the test in percent, okay? And what we see is that those students that get, 4 to 5 hours of sleep aren't doing so hot. But if they're getting 6 to 8 hours, they're doing a little bit better. But then you got this guy, okay? And then you got this person here. So they're not necessarily a guy, it's a person, okay? You have these 2 students here. And one thing I would say about this student is that how do you interpret this cluster? So you have this information, and then you're going, all right, well, what's going on with this person and what's going on with this person? So the person in red, this outlier, and what you can say about it is that this person got 2 hours of sleep, but they scored a 90%. So 2 hours of sleep, okay, and they got a 90%, okay? Now, this person probably stayed up all night and crammed for the test, okay? So they probably stayed up all night and crammed for the test. I don't recommend that, okay? I recommend starting your study habits weeks out so that you can get some good sleep and be fresh for the test. Now, this person over here, they slept for 10 hours, 10 hours of sleep, okay, and they got a 20%. So this person, and let me change this to blue, so 10 hours of sleep, okay, 20%. Okay, and the conclusion that you can draw, so I mean, this isn't necessarily true, that they stayed up all night and cramped, okay, this is what I'm assuming. Over here, the conclusion I would draw here is that 10 hours of sleep, okay, gives you a score of 20%. Maybe they overslept, okay? So overslept and panicked, okay? I don't really know, to be honest with you. But, that's something we could say. Or they just flat out didn't care. And they were just like, all right, well, you know what? I don't care about the test. I'm just going to sleep, and it doesn't matter what I get when I walk in the next day. But those are the outliers. So those are 2 different students that had 2 different outcomes that did not fit the data the way that it should, okay? And so those are kind of the conclusions we have to draw, all right? So over here on this next one, it says, how might the 2 outliers cause this scatter plot to be misinterpreted, okay? Very high values may cause a description of the data to be overstated. Very low values may be understated. So what we have is this. You've got this set of data, okay, and you have 2 different outliers here. Okay, you've got this one up here, and you've got this one up here. And what it says is that as the age of people increase, the sleep, average number of hours per night, is on a slow decline, okay? However, all right, so here's your cluster, but then all of a sudden you got these 2 pieces of data out here that don't fit down here. So what this says, the person that's in red, all right, that person is 30 years old, okay, 30 years old, and they're getting about 9.5 hours of sleep. So 9.5 hours of sleep, okay? And that's what that's saying, okay? The next person is 70 years old, okay? So 70 years old, and they're getting 10 hours of sleep, okay? So, what you did, you're grabbing a group of people and, you're analyzing this data, and all of a sudden you got this one person who's 30 years old that they get 9.5 hours of sleep. The other person here is 70 years old and they're getting 10 hours of sleep, okay? So, one of these, you can, and here's the deal with this, all right? The outliers don't necessarily, they can skew the data a little bit if we're talking about the averages, but if we're talking about the general trend of people, what we can say is that, so the general trend, let's write that. Okay, and I'm going to draw in this line here in green, okay? So the general trend is that as people get older, okay, they sleep less. And that's kind of true. Guys, I'm 32, and I'm not sleeping the sheer amount that I was when I was probably in my teenage years and my 20s. I could really sleep a lot. But I just find that, I'm just not sleeping as much. I am also going to bed a lot earlier now that I'm like in my 30s than I was when I was in my 20s. So I do wake up earlier. But I don't have that problem of, and maybe it's work, and maybe it's a couple other things, but I typically am in bed at 9 p.m., 9 to 10 p.m., and then I'm up at 4:30. So, I'm getting a solid, 7 hours of sleep. I could definitely sleep longer. That is a fact. But I've got a lot of work to do, so just like making these videos. So right now, it is currently 6:24 a.m., and I have been at work for a half hour making these videos. So, that's just kind of, just to talk about context of the problem. I do apologize, guys, that because I am going off on so many tangents here, but the data tells a story. And that's what's cool about it, okay? You can tell a story from the data. So, that's all I got for this. So hopefully you enjoyed this. Hopefully it makes sense. Sorry the video is a little bit long. It's longer than it should be. And we'll continue on. See you in a bit. Thanks a lot. Bye!